بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.4, Inverse of a square matrix and matrix equations. Well, if the product of matrices A and B, square matrices A and B, is the identity matrix I, then we say that B is the inverse of A, and also A is the inverse of B. And the matrix B will be called the inverse matrix of A, and we denote it by A to the power minus 1, or A inverse. So A and B are inverses of each other if A times B is I and B times A is also I. And notice that in this case, the multiplication of matrices is commutative. So we write B equals A inverse or A equals B inverse. They are inverses of each other. So here is the matrix A and B inverses of each other. Is B the inverse of A? So we need to check, we need to multiply these two matrices. If the product gives the identity matrix, then they are inverses of each other. So this is A times B. Remember how to multiply. 1 times negative 1, negative 1 plus 2, negative 1 plus 2 is 1. 1 times 2 plus 2 minus negative 1 is 0. 1 times negative 1 plus 1 is 0. 1 times 2 minus 1 is 1. So A times B gives the identity. What about B times A? So this time we start by B multiply by A. If you forgot how to multiply two matrices, go to the previous section, or maybe the one before. Negative 1 times 1 plus 2 times 1 is 1. Negative 1 times 2 plus 2, that's 0. 1 plus minus 1 is 0. 2 minus 1 is 1. So, yes, A and B are inverses of each other, or B equals A inverse, or A equals B inverse. True. Are these two matrices inverses of each other? Let us multiply A times B. So I'll use the calculator here, uh, or let me write to remind you how to multiply. So 1 times 3.5 plus 1 times negative 5.5. So that's negative 5.5. Negative 1 times negative 3, that's positive 3. 1 times 1.5, negative 2.5. Negative 1 times negative 1 is positive 1. Negative 1 plus 2, negative 1. So we are multiplying this row by the first column, then by the second column, then by the third column. This is how we multiply two matrices. Now the second column times the first column. 1 times 3.5 minus 1 times negative 5.5 is positive 5.5. And 3 times negative 3, that's negative 9. The second row times the second column, 1.5 plus 2.5, 3 times negative 1. The second row times the third column, negative 1 minus 2 plus 3. Now the third row times the first column, 4 times 3.5, that's 14. 2 times negative 5.5, that's negative 11. 1 times negative 3, third row times the second column. 4 times 1.5, that's 6. Negative 2 times 2.5, that's 5. 1 times negative 1. Third row times third column, negative 4 plus 4 plus 1. And now let us add and see the result. So this is 6.5 minus 5.5, that's 1. Here, 0. Here, 0. This is 9 minus 9, 0. This is 4 minus 3, 1. This is 0. 14 minus 3, 11 minus 11, 0. 1 minus 1, 0. 1. Is it? Yeah, it is the identity matrix. I leave it for you to multiply B times A, okay, and check whether uh, also you get the identity matrix or not. If you get the identity matrix, then you say that yes, A and B are inverses of each other. If not, then they are not inverses of each other. Okay, so it's not enough that A times B equals the identity. B times A also has to equal to the identity. Now, how do we find the inverse of a square matrix? To find the inverse of a square matrix A, and notice that the matrix has to be square matrix. So we talk about inverse because we need A times B equals I and B times A equals I. All right. So it has to be a square matrix. So to find the matrix of the inverse of this matrix, what do? We form this augmented matrix. Matrix A, we write matrix A, then vertical bar, and then we write the identity matrix. All right. And now we perform row operations on this matrix to change the matrix A, this matrix, the matrix A, to the identity matrix. So we change AI to IB. While we are changing this A to the identity matrix, this matrix, which is identity, will be changed to the matrix B. So for example, here, how do we change A to I? Well, first, this number is 1, so I need to make this number 0. So negative R1 plus R2. And now negative 1 has to be 1. And then I multiply negative 1, negative 2 R, or he used here 2R2 plus R1 to make this 0. So now you reach the identity matrix. So the matrix B, the new matrix here, is the inverse matrix. Okay, so that's the way, is the inverse matrix. So this is the procedure how to find the inverse matrix. Well, if you cannot reach the identity here, if you cannot change A to the identity, this means that A has no inverse. Okay, so if A has no inverse, then you will have 0 row. Okay, and you will not be able to change it to the identity matrix. We say here that, yeah, that B is the inverse of A. Okay, this is an example. Find the inverse of the matrix A. So we start by writing A. And then we write a vertical bar and we write the identity matrix. And now we change this matrix to the matrix A to the identity matrix. So the first number here should be 1, not 2. So I will interchange row 1 and row 2. And now I'll use this one to make 2 0. So negative 2 R1 plus R2. And this one also I need it to be 0. So negative R1 plus R3. The new matrix would be the first row, no change in it. Now negative 2 plus 2 is 0. Negative 8 plus 5. Negative 6 plus 4. Negative 2 plus 0. Whenever you have a 0, you put immediately the number. There will be no change. Negative 1 plus 1 is 0. Negative 4 plus minus 3 is negative 7. Negative 3 plus negative 2 is negative 5. 0. Negative 1 plus 0. And here we have 0. Good. Now, this number in the middle, I need it to be 1. So I will divide by negative 3. Negative 2 over negative 3. 1 over negative 3. 0. All right. Now, negative 4 R2 plus R1 to make this 4 0. And 7 R2 plus R3 to make the negative 7 0. There is no change in the second row. Okay. Negative 4 plus 4, that's 0. Now I'll use the calculator. Negative 8 over 3 plus 3. This is 1 over 3. Negative 4 times negative 4 over 3. Negative 8 over 3 plus 1. That's negative 5 over 3. And this is 0. So there will be no change here and no change here. Now 7 times 1 plus negative 7. 7 times 2 over 3 minus 5. 0. No, I multiply 7 times negative 1 over 3. That's negative 7 over 3. And 14 over 3 minus 1. Now this number has to be 1. So I multiply by negative 3. I multiply row 3 by negative 3. So there is no change here, but here negative 3 times negative 1 over 3 is just 1. And this one I'll have 7 here. Negative 3 times this. And negative 3 times 11 over 3 is negative 11. And here I'll have 0. And this one as it is. Negative 1 over 3. And 2 over 3 and 0. 4 over 3, negative 5 over 3 and 0. Now I use this one to make 2 over 3 0. And this is 1 over 3. So negative 1 over 3 R3 plus R1. And this would be the last step. I'll have now the identity matrix here. And this row will not change. Now, negative there is something wrong here because it's strange that this column is always 0. Negative R1 plus R3. Yeah, here negative 0 plus 1. This must be 1. This number must be 1. Okay. Negative R1 plus R3. This is 1. And now it is also 1 here. And now here 7R2 plus R3. Well, this one would be 1 also. And now when I multiply by negative 3, I will have negative 3 here. Okay. And now this is negative 3. And now negative 2 over 3 times 7. This is, I'll have negative 5 here. And that's a good sign. And negative 2 over 3 times negative 11. I will have 8 here. And negative 2 over 3 times negative 3, that's 2. Okay, good. Now the first row, negative 7 over 3 plus 4 over 3, that's negative 1. 11 over 3 minus 5 over 3, that's 2. And 1. So A inverse, now A inverse is this matrix. And you can check your answer by multiplying A times A inverse, and you reach the identity or not. Or you can go to mode matrices 6 and press 1, matrix A, 3 by 3. So choose 1 and write the matrix elements. So 2, 5, 4, 1, 4, 3, 1, negative 3, negative 2. And that's it. Now press on and go to shift 4, that's matrices, shift 4, shift matrices, and go to matrix A, which you entered, and press X to the power negative 1. Okay, so he will give you the inverse. And the inverse is negative 1, 2, 1, negative 5, 8, 2, 7, minus 11, minus 3. So my answer is correct. So that's how you check your answer by the calculator. Well, to find the inverse of this matrix, I write 1, 0, 1, 2, 1, 2, 1, 1, 2. This is the matrix A. And then I write the identity matrix. Now this is 1 good, so I will multiply row 1 by negative 1 and add to row 3 to make this one 0. There is no change in row 2. Now, negative 1 plus 1 is 0. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. Negative 1 plus 0 is negative 1. Zeros, so there is no change here. Good. Now this number is 1. So I just use it to make the two zeros. So negative 2 R2 plus R1. This matrix is easy. This is the third row, and also the second row, there is no change in it. Okay, now the first row. Negative 2 plus 2, that's 0. Negative 2 plus 1 is negative 1. Negative 2 plus 0 is negative 2. And I have 0 here. Good, so this number is also 1. So I use it to make 1 and negative 1 zeros. So negative R3 plus R2, R3 plus R1. So there is no change in R3. And now I have the identity matrix here. Negative R3 plus R2, negative 1 plus 1 is 0, okay. 1 plus 0 is 1. This is 0, it will not change these numbers. Negative 1 plus 0 is negative 1. Now R3 plus R1, negative 1 plus 1, this is 0. And 1 plus 0 is 1. So A inverse is this matrix 0, 1, negative 1, negative 2, 1, 0, 1, minus 1, and 1. And you can check your answer either by calculator or by multiplying A times A inverse. Well, this technique can be used to find A inverse for any matrix, any square matrix A, if it is possible, okay, if A inverse exists. However, there is a special formula for the 2 by 2 matrices. If A is 2 by 2 matrix, only 2 by 2. This formula is not used for any other dimension. So A inverse would be 1 over AD minus BC. So this is AD minus BC. 1 over AD minus BC times AD, we change their positions, DA. BC, we keep their positions, but we multiply by a negative sign. So this is how to find A inverse. Of course, if AD minus BC is not 0. If AD minus BC is 0, then A inverse does not exist. So let us try to find A inverse here. 1 over 3 times 5, 15, AD minus BC, 2 times 7, 14. 3 and 5 change positions. 2 and 7 keep positions but multiply by negative. Now 15 minus 14 is 1. 1 over 1 is 1. So this is A inverse. And if you multiply A and A inverse, you should get the identity matrix. Well, for this matrix, let us try to find B inverse. 1 over 2 times 2, that's 4 minus. Negative 1 times negative 4 is 4. 4 minus 4 is 0. So there is a problem here, and this matrix has no inverse. The inverse does not exist. The second point in this section is how to find or how to solve the matrix solutions, systems of equations using matrix equations. So we have a system like this. We can write it like this. This is the coefficient matrix times the variables x, y, z, variable unknown matrix, equals the constant matrix. So if you multiply this matrix, the coefficient times the variable matrix, the unknown matrix, and put it equal to the constant, you will get the three equations. For example, multiply this row by this column. So 2x plus 5y plus 4z equals 4. That's actually the first equation, and so on. So this matrix equation represents the system, represents the system. Well, how to solve this matrix equation? This is the matrix A, and this is the matrix X, and we have A times X equals B. So if you find A inverse, if A inverse exists, then if you multiply from the left hand side by A inverse, multiplication of matrices is associative. So I can write it like this. A inverse times A is the identity matrix. Identity times X is X. So X will be equal to A inverse B. So if AX equals to B, X is A inverse times B. This means to find XYZ, to find this matrix X, you need to find A inverse and multiply by B from the left. So, for example, use an inverse matrix to solve this system. Well, first I need to write it in the form AX equals B. So what is A? The coefficient matrix 2, 1, 1, 5, 4, negative 3, and 4, 3, negative 2. This is the coefficient matrix times the unknown matrix x, y, z equals the constant matrix 4, 1, 5. So this is the matrix A times x equals B. All what I need to do is to find A inverse. Well, to find A inverse, I have to uh, find A inverse as usual. But did we see this matrix before? Did we find its inverse? Do we know its inverse here? Yeah, isn't it? Isn't it this matrix 2, 5, 4, 1, 4, 3, 1, negative 3, negative 2? Exactly. So we have A inverse. So X would be equal to A inverse times B. What is A inverse from the previous question? This is A inverse, okay. Yeah. Negative 1, 2, 1, and negative 5, 8, 2, and negative 7, 7, negative 11, negative 3. If the inverse wasn't there, we have to find it first. Times x, y, z. Okay. No. X would be A inverse times B. X is xyz. So this is xyz. This is x. And here I have B, which is 4, 1, and 5. This is 3 by 3 multiplied by 3 by 1. You get 3 by 1. So negative 4 plus 2 plus 5. Okay. Negative 4 plus 2 plus 5 will give you 3. Negative 20, I'm multiplying the second row by the second column, plus 8, okay, plus 10. So that's negative 2. 7 times 4, 28, negative 11, negative 15, and that's 2. So x is 3, y is negative 2, and z is 2. This is the solution of this system using the inverse matrix. Same here. What is the coefficient matrix? 7, 2, negative 5, negative 3. This is the coefficient matrix. A. X is the matrix, X and Y in this case. And B, the coefficient matrix, 12 and 6. We need to find the inverse. Did we find it before? No, it isn't. It wasn't one of these two. So let us find the inverse. Well, to find the inverse, I write no, I will use the rule. I have a rule to find the inverse of 2 by 2 matrices. We just mentioned it. So 1 over 7 times negative 3, negative 21 minus. Negative 5 times 2, negative 10. So it would be positive 10 over 7 and negative 3 change positions. 2 and negative 5 keep positions but change the signs. Negative 21 plus 10 is negative 11. So I have negative 1 over 11 times negative 3, 5, negative 2, and 7. Will multiply negative 1 over 11. So I have 3 over 11 here, negative 5 over 11 here, 2 over 11 here, and negative 7 over 11 here. Now this is the matrix A inverse. So X, which is the matrix XY, would be equal to A inverse, which is this matrix, over the matrix B, and let us multiply these two matrices. What do you get? 3 over 11 times 12 negative 5 times 12 over 11. So again, yeah, 3 times 12 over 11 minus 5 times 12 over 11 negative 24 over 11. And 24 over 11 minus 42 over 11. This is negative 18 over 11. So X is negative 24 over 11. Y is negative 18 over 11. To check my answer, I will use the calculator. Mode 5, 1. To solve the system, I put 7, negative 5, 12, 2, negative 3, and 6. I have the first, X is not correct. X should be 6 over 11. So let me check it again. 3 times 12 over 11 minus 5 times 6 over 11. Yeah, it's 6 over 11. So I made a mistake here in multiplying. So this is actually 6 over 11. Good that I checked my answer. Also, you can check your answer by replacing here x and y by these values and check whether they satisfy the equation or not. The last point in this section is the determinant. How to find the determinant of a 2 by 2 matrix A. Well, you remember we said that A inverse is given by this formula, and we said that AD minus BC shouldn't be 0. Well, AD minus BC is the determinant of A. So, determinant of A, B, C, D, and this is the we wrote it like we write it like this, or we can write determinant of A. Okay, if this is the matrix A, it is equal to AD minus BC. So the determinant of a matrix is just a number associated to the matrix. Okay, so any matrix has a determinant. Just multiply AD minus BC, 2 by 2 matrices. So here, for example, find the determinant of A. Well, determinant of A would be equal to 2 times negative 4, which is negative 8, minus 3 times 4, that's 12. So negative 20 is the determinant of this matrix. Notice that if the determinant of the matrix is 0, this means that AD minus BC is 0, and this means that the inverse does not exist. Hope you enjoyed this section.